Hi, my name is Neil, and I know I haven't made a video in very long, but I wanted to show you a robot that I've been building for the past year. If you want to follow along and build your own robot, I've created a series of blogs that can help you learn robotics, some Python, and build this robot. This video will contain demos, tuning of the robot, and some assembly instructions. Here is the robot, and let me give you a quick walkthrough of all of the parts. On the underside, you can see we have two motors, one on each side, a motor assembly to connect it to the main body, and some wheels. We also have these caster wheels, which make sure that the robots don't fall over, but do not constrict the motors from moving around. Here on the front you can see our three sensors. We have two IR sensors and one ultrasonic sensor. These are all connected to our Raspberry Pi. On top of our Raspberry Pi we have the motor shield, which we're connecting our sensors and the motors to from these wires here. And we have the Pi beneath it. Now for the bit that powers it all. This module contains all the batteries, and it connects to this, which is a buck converter. A buck converter allows us to convert the 7.5 volts of this into 5 volts that we can run into the Raspberry Pi and motor shield. On to our next step. We have to manage the voltage. These two batteries are both connected and yield an output of about 7.5 volts. And this is too much for the Pi and motor shield. It might act even shorted. So we have this thing here, which is called a buck converter. It's connected to the Raspberry Pi and motor shield for output, and its input is the batteries. As always, the more finer details and instructions are on the blog, but you will see that over here is the potentiometer. Move this very slightly when connected to a multimeter to tune it. Now let's tune the motors and sensors, starting with the IR sensor. First, position the Raspberry Pi about 25 centimeters away from a wall. Then run the program. As you can see, we have the calibrated number, and that will be saved in a file so that we can use it in some of our other programs. Now, the next thing we need to do is calibrate the motors. So there's two things we need to do in the motors. One, since all of our motors are not exactly the same, we need to add an offset to one of the motors to counteract for any drifting there may be. And second of all, since these are DC motors, if you flip the connectors, meaning the power is going to the ground and the ground is going to power, the motors will actually be reversed. So to counteract this, we have to run our polarity calibration. So what this should do is it should be turning right, but in this case, since we have swapped the polarity on one of our motors, it's actually going forward. So now all we need to do is enter forward in the program. And again, the program will save this data in a file so that we can use it in another program. Now let's run the drift program. This is a bit more complicated, but it's nothing too much. You have to find a long space so that the robot can go forward, and you run it. as you can see, our robot seems to be drifting a little bit to the left. So we're going to enter the direction it's drifting in and how much it's drifting in. In this case, it's only drifting a teeny bit, so I'm going to put 1. And it's going to run the same thing over again so that we can make sure that it's been calibrated properly and allow for further adjustment. Now, as we can see, it is running pretty straight, so we're good. If we press enter on this program, then again it will save that data so that we can use it later. Now for the last sensor, our IR sensor. Now here we're going to have to do some hardware work. First, run IR test, and you can see that we have the raw input, and it'll tell us if an obstacle is detected or not. So what we have to do is turn this potentiometer knob all the way down and then turn it back until it lights up again. Once it lights up, we just turn it down until it says that there's no obstacle detected. Do it again. We turn it down until there's nothing detected. Okay, so I turn it down so there's nothing detected on the IR sensor. Then we turn it back up until something is detected, and we put it just below that to get our maximum range. Now, as you can see, the raw input is 1 for both of them, meaning that there's no object in front of them, which in this case there isn't. And if we put a water bottle, for example, in front of them, then you can see that it detects it. See, obstacle detected in front of left IR sensor. Then, if we put it in front of the other one, you can see it's in front of both of the IR sensors. Now, let me show you a demo. Now for the moment we've all been waiting for, the obstacle avoidance. As you can see, the robot moves forward, and as it sees a wall, it turns away from it until it sees no wall anymore. If I put my hand here, it will move away from it. As you can see, without fail, it does not bump into anything in these corners. And there you have it, a fully autonomous robot that is capable of avoiding obstacles.